Hello, I'm Patrick Hwu, SITC President and CEO of the Moffitt Cancer Center in Tampa, Florida. We're so honored today to have Dr. Steven Rosenberg, Chief of the Surgery Branch at the National Cancer Institute, where he's held that position since 1974. Dr. Rosenberg has been a true pioneer in immunotherapy, doing immunotherapy when no one else believed in it. He really helped to bring forward the field, showed the first efficacy, helped the first FDA approval of the initial therapies for melanoma and kidney cancer that show long-term survival for some of the patients with metastatic melanoma and kidney cancer. And he's trained hundreds of people who are now leaders in the field. So thanks so much, Dr. Rosenberg, for being here. It's especially a special honor for me, especially since I spent 14 years with you at the National Cancer Institute, where you taught me so much, not just about science, but about leadership and just the ethics of and the importance and urgency of doing cancer research that was translational and helped patients. So thanks so much for being here today.
My great pleasure, Pat. It's so nice to talk with you again.
Tell us, how did you first get into science?
So I remember as a child wanting to be a cowboy. I have an older brother, and we would talk about going out west and riding on horses. But when I became about 6 or 7, I developed what was almost a spiritual desire to get into science and medical research. And as I've thought back about what occurred to me at that time, I was born in 1940, and I was about 6 or 7 right after the war. And I remember being just horribly affected by the stories that came out about what happened in the war, as my parents got postcard after postcard about relatives that had died in the death camps. At that point, something switched in me, and I decided that there was so much evil, there were so many bad things that people seemed to be doing to one another. I wanted to do good things. I wanted to be kind to people. And it seemed to me, even at that point, that doctors who were taking care of people who were sick were solely devoted towards alleviating suffering. And I decided that's what I wanted to do. I started keeping scrapbooks about every item I could find about some aspect of medical research. And it's entirely possible that that's what led me to study cancer as well, because in cancer, you're taking care of innocent people who are suffering because of things that were no fault of their own. They and their families had to just watch by impotently as they slowly died. It occurred to me that cancer was like a Holocaust. And when I began to take care of patients, especially as a resident, and saw a lot of cancer patients that as a surgeon I would operate on, but would ultimately die regardless, that it seemed to me that cancer was something that I could immerse in and make a contribution to.
Tell us a little bit about your parents. Were they in science? I know you grew up in New York City, right? You went to the Bronx School of Science there.
Bronx High School of Science, yes. No, my parents immigrated to the United States in their late teens. They met here in this country. They immigrated here from Poland. Neither got beyond about 5th grade in education because they were constantly trying to avoid horrors in Poland. They came to the United States and met here and married. I was born in the Bronx, and as you mentioned, my interest in science and medicine led me to the Bronx High School of Science, and then Johns Hopkins, and then on with my education. But my parents were smart. My dad owned a luncheonette. My mother worked in the luncheonette as well, as did I, and every day after school when I was in high school. But it was a loving family.
I remember you telling me about working summers and flipping burgers, and at your picnics, you were really good at making hamburgers, actually.
Yes, no, I worked behind the counter at my dad's luncheonette most summers, and certainly every day after school when I was in high school. Just trying to help out. My dad worked. He left the house at about 5:45 to 6 o'clock in the morning, never came home till 6 o'clock at night as he was running a luncheonette trying to support his family. But yes, I probably made 10,000 egg creams in my life behind the counter of that store.
Well, it certainly inspired a strong work ethic in you. I remember we used to be able to set a clock. You were there every day and so long, and Saturdays, and worked so hard all of the time, outworking everybody in the lab. So tell me, when you started working on immunology, there really wasn't very few people working on immunology at the time for cancer research, and a lot of people that didn't believe it was ever important. What stimulated you to think that the immune system could fight cancer?
So I got interested in immunology when I was a graduate student in the midst of my residency, and studied cell membranes, the biophysical chemistry of cell membranes. And so I had an interest in immunology, but it was actually contact or exposure to two patients very early in my training that pointed me in the direction of immunotherapy for cancer treatment, that then blossomed when I started to see cancer patients as a resident. The first was a patient that I saw when I was a senior resident at the West Roxbury VA Hospital. We rotated there from the Peter Brigham Hospital. And I saw a veteran who came in with upper right quadrant pain. He had a gallbladder attack. I was pretty excited about it because it meant I might get to do the surgery to remove his gallbladder. But when I opened his chart, I found out that 12 years earlier, he had been at the West Roxbury VA Hospital. He was a veteran. And he had a gastric cancer. He was operated on. It encompassed 2/3 of his stomach. They took out part of his stomach, but they biopsied multiple liver metastases. He had a lot of positive nodes, and they just left them in place and sent him home. And then as they turned the pages of his chart, he showed up again in clinic 6 months later, and then a year or two later, gaining weight. And here he was now 12 years later, completely disease-free. I operated to remove his gallbladder under supervision, and there was no cancer present. And we checked the pathology. We checked to sure it was the same patient. Somehow he had undergone one of the rarest events in all of medicine, and that is spontaneous regression of a metastatic cancer in the absence of any treatment. It seemed that somehow his body had learned how to destroy that disease, and that impacted on me greatly. In fact, right then, we had another patient in the hospital, a veteran who had a metastatic gastric cancer. He had the same blood type. And I asked the director of the hospital if I could transfuse blood from the patient who had the spontaneous regression into the patient who now had an active cancer, thinking that maybe it might help. And of course, it didn't do anything, but it at least planted the seed that there was maybe something that was present in that cancer patient, maybe something in their blood that could impact on the growing cancer. And there was a second patient that also impacted on me, who had been seen at the Brigham just 1 or 2 years before I got there. It was a patient who had received a kidney transplant from a young man that died in an automobile accident, and that kidney contained a renal cancer, unbeknownst to the transplanting surgeons, that was inserted into this patient receiving the transplant. And sometime later, that patient, the recipient, developed widespread kidney cancer. They then took out the kidney. He was on immunosuppressive drugs. They stopped the immunosuppressive drugs. His cancer rejected, and they had to remove it and replace it. But all of his metastatic cancer disappeared. And that taught me that, in fact, even large, bulky, vascularized cancers could be rejected if the immune stimulus was strong enough, in this case, alloantigens from another patient. And so here was evidence for an immune reaction probably causing cancer regression. Here it was the immune system clearly responsible. And I thought of those cases a lot when I decided what I wanted to pursue, and that was the development of perhaps deliberate immune approaches to treating cancer.
That's right. I mean, you were so well ahead of your time. It was also a rocky road because many of those early treatments didn't work. Many people in the field not only didn't believe it, but almost ridiculed it. So how did you pursue and push forward despite the challenges early on?
Well, good question. I came across this statement attributed to Abraham Lincoln that said, "Success consists of moving from failure to failure without loss of enthusiasm." And somehow you're right. When I try to pull my thoughts together back in the 1990s, it turned out I had treated 76 consecutive patients with metastatic cancer. First, utilizing interleukin-2, that was obviously an immune stimulant that had been described in 1976 by Morgan, Rossetti, and Gallo. It seemed like stimulating the immune response with interleukin-2 non-specifically might be a good idea. We made our own IL-2 in the laboratory and gave it to some patients. We got IL-2 from DuPont and then from CETUS. Again, treated 76 patients with either IL-2 or lymphokine-activated killer cells, non-specific killers we could generate with IL-2. And none responded. It was only the 77th patient. A woman well known to you, probably Linda Taylor, who's been in the news and talks about our illness a lot, who we gave very high doses of interleukin-2 using an every 8-hour schedule that was demanded by the pharmacokinetic studies we were doing, showing that the in vivo half-life was only 7 or 8 minutes of interleukin-2. And she had a dramatic regression of all of her disease and is now, 35 years later, remains disease-free. And so it was in utilizing that almost eureka moment, the first patient that actually did respond to a strictly immunologic maneuver. Tumor cells don't have IL-2 receptors, lymphocytes do. That was, for me, the first demonstration that this was not all in vain, that it was possible. It wasn't only a dream, it was actually possible it could happen. And once you know something can happen, your whole attitude changes. Before you've seen that, you're always worried maybe it'll never happen. But that patient taught me that it could, and we went on to treat almost 200 patients with IL-2 and showed that, in fact, this could be a reproducible phenomenon in about 15% of patients with melanoma and renal cancer.
And it certainly led to the FDA approval of one of the first immune agents, interleukin-2, for metastatic melanoma and metastatic renal cancer. It also maybe wasn't approved based on response rate, but that durability of response to the tail of the curve. Tell us a little bit about the immune system and why that might be important compared to response rate, the durability of the response.
Well, there are a lot of things that can cause temporary shrinkage of tumors. And that's, in some sense, been the huge thrill as well as the bane of the use of chemotherapy, that can commonly cause tumor shrinkage, but when one has metastatic disease, can virtually never cause the cure of metastatic solid epithelial cancers, common cancers like breast and colon, the cancers that start in the ducts of the major organs of the body that are constantly turning over, and as they turn over, mistakes are made, and those mutations ultimately lead to the disease. And so it was in the course of those kinds of studies that the immune system sort of it looked like it was going to be very, very important. And those two examples of patients that I saw sort of solidified that in my own mind.
You have been in the same official role since 1974, working for the federal government at the National Cancer Institute. Tell us why you stayed there and what the federal government and the National Cancer Institute, in your opinion, has done for the field of immunotherapy.
Well, I can tell you what it did for me. As you know, I'm a worker bee. I'm pretty down the hierarchy of people here at the NCI. And have had very little influence of the NCI outside of this institution. But this intramural program, the Clinical Center Hospital, is quite unique. It's, in my view, the world's greatest research institution and hospital, an opportunity to do basic research, and with really huge resources take care of patients who are not charged for their care, which gives one a major opportunity to perform kinds of experimental treatments that are very difficult to perform elsewhere. And I've had plenty of opportunity to move from the NCI, but for me, this was always the perfect dream position, a position where I could devote myself to work in the laboratory, to work with very bright people who come through, and as quickly as possible translate that into patient care. So for me, it was almost ideal. The June 30th, 1974, I was sleeping in a call room as the senior resident in surgery, and the next day I was appointed chief of surgery, July 1, 1974, and it's a position I've held the last 46 years. I've been very lucky to be able to continue to work here and meet so many remarkable people like you, Pat.
Thank you. So, the field of immunotherapy right now is just totally taken off. It's hot, and everyone just assumes that the immune system can kill cancer, but it wasn't like that for the first few decades. So how did you keep the excitement in the field together? I mean, how did you keep people believing that this was possible? How did you keep training people, attracting people to the lab, moving forward when really the whole field of oncology, and you were there before me, but even when I started with you, no one believed it. So what did you do to keep that resilience and move it forward?
Well, you're right. There was a great deal of pessimism about the value of the immune system in trying to treat cancer. There's a famous quote from Cancer Research by Dr. Woglum, who published that it would be as difficult to reject the right ear and leave the left ear intact as it would be to use the immune system to cause cancer regression. There were many debates going on, even in 1974, between an English scientist, Hewitt, who was claiming in 1974 that there was no such thing as an immune response to human cancer, that all of the work on experimental animals that could show that you could prevent cancer by immunizations was just not relevant to human cancers. No one had ever identified a cancer antigen or actually even measured an immune response in patients against cancer. And in fact, I spent the first couple of years trying to look for humoral antibody responses against cancer before we started manipulating T cells. And so it was an intuition. And in research, it's having that intuition based on a body of knowledge, a basis of knowledge that I think teaches us what to study. And in fact, paying attention to patients can teach one a great deal that one cannot get insights from reading books or reading papers. And so it was in seeing patients that the ones that I mentioned, about seeing patients that were progressing despite everything that we had available to offer, that kept me going. The idea that maybe we could find a new way to join surgery and radiation and chemotherapy to treat cancer, because although those could cure perhaps half of people who develop cancer, the other half will go on to die regardless of everything else we did. And so we kept at it. We kept learning. We kept looking at animal studies as well as in the human. And then you played an instrumental role as we decided to try to modify lymphocytes, genetically modify them to try to improve cancer treatment. In fact, you were the first person ever to use CAR T cells in treating people. That ultimately then became very, very important. But, there were probably 40 days in the first 40 years that I worked at the NCI when I was not in this hospital, either going over research data or seeing patients. And that can take a toll. That can consume people. And I was fortunate enough to have a wife, Alice, and 3 young daughters who understood what I was trying to do and provided enormous support for allowing me to immerse myself in that field.
Well, you certainly have a beautiful family. That's for sure. You know, what I've been impressed, you've had some amazing papers. Your H-index, all of those metrics are very high. But in knowing you, that was never your goal. You've always been driven to take the laboratory data to the patient. A lot of people are intimidated by that. They call that the valley of death. It is so hard to bring things from the lab to the clinic, but you've always managed to do it. So how have you done it? Especially, with continued increasing regulatory issues, you've always brought, it doesn't matter what the idea is, you've always been able to successfully translate things from the lab to the clinic, and that seems to be your passion. How is that? How have you been successful in doing that?
Well, I've always had the feeling that the best experimental animal for exploring new scientific principles was the human, and that one could learn a lot in the laboratory and in mouse studies, but it was in human reactivities that one could find the truths that one needed to understand to make progress. Now, everybody we were treating had advanced cancer with very limited life expectancies, and everybody that we treated has been through all standard treatments, and they haven't been helpful enough for those patients. And so the combination of having flexibility here at the NCI, a passion to try to help people, which just was so pervasive in my thinking, that in retrospect, I did some things that probably weren't terribly wise when I was getting started, but it was in a desperation to do something. I mean, that first blood transfusion from one patient to another wasn't exactly founded in science. We actually treated 6 patients before we could manipulate lymphocytes outside the body. We treated 6 patients with cells from mini pigs that had been immunized against human antigens with the hope that those lymphocytes might, before they were rejected, cause some anti-tumor responses. They're an incredibly, in retrospect, naive and simplistic approach to doing things. But it was this urge to take things to people that might help them that propelled me along, and ultimately that one patient made an enormous difference in my thinking, because that taught me that at least might be possible, and it's turned out to be correct. I believe. I think it is possible. There's a long way to go, but I think progress is being made. We're almost on a monthly basis now.
Well, you've always been so impressive in bringing work from the lab into the clinic, I have to tell you. And I think the surgery branch of your lab right now are doing some of the best work ever. Despite all your successes, you're now doing some of the best work ever currently. Now the public understands that the immune system can kill cancer. I think that's not controversial anymore. We have some really great therapies for melanoma, for lung cancers. You've worked with T-cell therapy, with CAR-T. Now we've had approval of CAR-T therapies, a lot based on your initial work with the CD19 CAR-T, and now that's going on and moving forward. You're working with mutation-specific T-cells. So now what? Where do you think the field needs to head to get to that next echelon of success in patients and decreasing deaths from cancer?
Well, you and I lived through the era when immunotherapy, studies of cancer immunology, were at the very periphery of cancer research. And we're at the very periphery of immunology meetings as well as cancer meetings. I remember once going to an AACR meeting, and there was a session on PARP inhibitors, and there must have been 1,500 people in the audience. And then they said, okay, now we're going to move to an immunology session. It was the last one at the meeting. And there might have been maybe 35 or 50 people left in the audience when I began to talk. So you're right. This is a field that did not gain a lot of respect. It was on the periphery of both of those fields. Now it's mainstream, as you point out. And we have enormous leads because of the brilliant work that's been done with the checkpoint modulators. We know that, in fact, lymphocytes can be present and not active and be made to be active by inhibiting certain cell surface molecules. And the field of the development of additional of these checkpoint modulators, I think, is going to be very important. we have proof that lymphocyte transfer can mediate tumor regression. That is, it is the immune cells that are the major part of the immune system that results in tumor regression. But we need to make better cells that are less differentiated, less exhaustive, so that they can fulfill their effector potential. We need to understand what the inhibitory factors are in the microenvironment that keep the cells from working. But we now have examples, solid examples, of the ability of T-cell therapy to cause the regression of metastatic solid epithelial cancers. You know, if we look at the 600,000 people that died of cancer in this country last year, 90% of the cancer deaths were due to deaths from the solid epithelial cancers, all the way from the rectum up through the stomach, the esophagus, the prostate, the ovary, you name it. Any organ that has a gland has ducts that are turning over and can become malignant. And I see that as the greatest challenge we now face. How do we impact on these 90% of cancer deaths due to epithelial solid cancers? But we know that by T-cell transfer, we've seen dramatic regression, ongoing now 6 years later, in a patient with metastatic breast cancer who got cells with IL-2, colon cancer by targeting KRAS that we published in the New England Journal, HPV-induced tumors can be made to respond as well. So there are examples now of what would otherwise have been considered intractable patients with metastatic solid cancer that can now be treated with immunotherapy, with T-cell transfer. And of course, in the large tumor mutation burdens with the checkpoint modulators. So I think it's improvements in that area, now that we know it can happen, can work, that it's going to involve me. And you say I've been doing this a long time. Tell you the truth, I've really felt in the last couple of years that I've finally gotten the hang of what needs to be done. And in many ways, I feel like I'm just getting started. I plan to keep at it for as long as I can.
Wonderful. What do you think the future holds? 10, 20, 30 years from now, what do you think a person, I think people will still be getting cancer, and if they get cancer, they're going to a doctor. What do you think the treatment's going to be then?
So we've had surgery with us for over 2,000 years. There are Egyptian papyri that talk about cancer being cut out. We've had chemotherapy, which we date to chemical warfare research during the Second World War in 1942, where nitrogen mustard that caused laboratory workers to be exposed accidentally would develop lymphopenias. That led to the first application of chemotherapy for cancer. Radiation therapy dated from the year after Röntgen discovered X-rays in 1895. So we've had these treatments around, and they've constantly been improved over time. But these have been tiny improvements, and we're confronted today still with the situation that tells us that if you have metastatic cancer from any one of these solid epithelial tumors, you're not going to be cured by anything that's now available. But we have examples with checkpoint modulators. You can get durable responses. With immunotherapy, durable responses. And I would imagine that all three of those original treatments will continue to be improved. And after all, they can cure. I mean, long-term cure a little over half of everyone who will develop cancer in the year 2021. But I think we're going to see immunotherapy having an increasing impact, not only alone, but also in conjunction with those treatments. And we're already beginning to talk about immunogenic chemotherapies compared to non-immunogenic chemotherapies, depending on the mechanisms by which they destroy cancer, by abscopal effects of irradiation that might lead to improved immune responses. I haven't seen any convincing evidence of that yet, but it certainly makes sense. And so I think we're going to see the continued use of these four modalities in combination, and hopefully new ones will come along as well.
Where do you think vaccines are going to stand? You know, we have had some great successes with the RNA vaccination methods for COVID, and it seems to be quite a potent vaccine stimulating T cells. Do you think that's going to enable us to get some vaccines to work in cancer therapeutics?
You know, I certainly hope so. because it's so straightforward and simple and non-toxic. And you lived through time in the surgery branch when we treated over 600 patients with every kind of vaccine that we could think of, generally trying to immunize against the wrong antigens, incidentally. But now that we know what cancer antigens are, for the first time in the last few years, it appears as if cancer antigens arise from any somatic mutation that encodes an intracellular protein. And about 1% to 2% of those mutations form small peptides that can fit on the MHC molecules of that particular patient. And these turn out to be unique for every patient. And so in 76 melanoma patients, we found almost 100 antigens. Everyone was unique to the individual patient. In 195 now consecutive patients with epithelial cancer, we found almost 300 antigens, and with the exception of a single KRAS mutation, G12D, restricted by CW0802, every other one of those antigens was unique only to the patient who had it and not shared by any other patient. And by immunogenic, I mean T cells in that patient could recognize the cancer. And so perhaps we have an opportunity now to finally immunize against the right antigens, these mutation products. And in fact, we use an mRNA vaccine that was produced by Moderna about 2.5 years ago to see if we couldn't use RNA vaccines to immunize patients, and we could not. We saw no anti-tumor responses in any of the prior 600 patients with vaccines, and even the more recent ones. But hopefully, if good adjuvants can be developed and we can pick the right antigens, maybe vaccines will work someday. But I do not believe that there is any current convincing evidence that cancer vaccines can make large vascularized tumors disappear the way we can with T-cell transfer. So hopefully that'll change. But right now, vaccines have not yet proven themselves to be effective.
So you've trained hundreds of people in the field of tumor immunology. What's that meant to you, and what advice do you have for emerging scientists now coming out of their training?
Well, mentoring fellows has always been very important to me. And we've had, as you pointed out, hundreds of fellows come through, and they're on the walls right outside of my office that go up and down the hallway. You know, fellows can see what's important to people. And it's always been my philosophy of leadership and in mentoring fellows that you lead not by fear or by setting deadlines. You lead by acting in a way that causes fellows to not want to let you down. They see you working. They see you working hard. You lead by example, and fellows respond to that and want to support what you're doing because they think it's important. Now, what are the features? Probably the most common question I'm asked by fellows is what does it take to make progress in doing research? Obviously, you have to be smart, but you assume people who have gotten this far are smart enough. But there are two factors that I've found, not only in myself, but in other fellows who I feel have done extraordinarily well. And I saw it in you and several other fellows who have accomplished so much in the field. The first is a passion for what you're doing. Now, passion is a little bit of a cheap word. It can mean a lot of things. To me, it means the desire and ability to immerse yourself, almost to immerse your working life in the goals that you're trying to pursue. So that when you're taking a shower or you stop at a red light and you can't think about you just have to think about things. There's nothing else you can do. You're thinking about the work. You're immersing yourself in that field. It was one of the reasons why I went on, got a PhD in biophysics. I wanted a broad base of information that I could bring to bring to problems, and be able to immerse in a variety of fields that might help the goals that I had. So immersion in the field is something I urge all our fellows to do the first day they arrive here. The second is a laser focus on the goal that you're trying to achieve. Every time you do experiments in the lab, you get some strange findings. There's things that are very interesting that you might want to pursue in some detail, and making careful choices about what you pursue. That's not to say you shouldn't take advantage of unanticipated findings. You should. But it's picking those findings that will, in a laser focused kind of way, take you to the goal you're trying to achieve, that I think is the second really important factor. And that's something that I try to teach to our fellows.
Yeah, there are other advice that I remember getting from you. One thing is, I don't know if anyone's ever tried to invite you somewhere, but it's very hard to get you to get on a plane and go somewhere else. You spent a lot of time in Bethesda, Maryland, going into the lab, doing your work. Can you give any advice to trainees about traveling?
I think, when you're just getting started, there's enormous stimulation in going to meetings and seeing the excitement that people have about what they're doing. And I think early on in one's career, it's valuable to be exposed to that kind of atmosphere, as well as to a lot of subjects that you're not studying, and might develop methods for applying to your own goals. But as you get on, I think all those hours in airports and in airplanes are just not an efficient way to make progress. And so I try to limit the amount of traveling that I do as much as I possibly can. And that's even more so now when we're so deeply involved in these new approaches. I just feel I need to be here to help guide things along. Now, mind you, the overwhelming amount of work that we've done has not been done by me. It's been done by fellows and staff who come through the NIH. But the ability to see them on a Saturday or a Sunday, or to get together with them early or late in the day, I think is very important, not only to me, but to our ability to keep making progress.
Well, we're certainly glad with all of your laboratory work that you have often decided to come to SITC. So we've seen you there frequently. So we really appreciate that. Are you planning on coming to SITC this year?
Absolutely. Can't keep me away. I'll be here. I'll be there in person, of course. And I hope a lot of people do. Such an important time for the field because of the opportunities that we have. I think any young people who show up at SITC are going to come away thrilled with the ability to make progress along many of the subjects we're going to hear about this year.
Well, we're really excited last year to establish our endowed Steve Rosenberg Award to young trainees to just not only to recognize your contributions to the field, but also your contributions to mentorship, because a young faculty member gets that every year now. And so we'll be doing that again. Tell us what that award has meant to you.
Pat, of any recognition that I've gotten, none have been as impacting and profound on me as getting this, getting SITC setting up this Rosenberg Scholar Award that will give funds to young people just getting started in the field and encourage them to do that. I've gotten a lot of prizes over the course of the last years, and they're nice to get, but they're also a little bit embarrassing to me because I'm being singled out to get this prize when I know that it's been dozens and hundreds of actual other fellows and staff who have done so much of the work. And so I take those prizes with a little bit of a little grain of salt, since I know they're not only for me, but for all the people that have worked here. But this mentorship award just means so much, because I've devoted so much of my energies in life to trying to help younger people develop progress in science, that the idea that SITC will be providing the impetus and funds to enable increasing numbers of these young people to study cancer immunology and immunotherapy just means a great deal to me. And my thanks to all at SITC that helped make this come about.
Well, you've certainly had a profound influence on me and my career and all I've learned carrying forward. So I really appreciate personally, but SITC is really honored to do this for you and someone who's just influenced the field so much. SITC, as you remember, used to be the Society for Biologic Therapy, or SBT. You remember those days?
I certainly do. In fact, even before that, the journal that became SITC's journal was called the Journal of Biological Response Modifiers. People were afraid to call it immunotherapy because of all that went along with the lack of success in that field. But SITC then became an organization, an opportunity to bring people who were passionate about the field together. And I think it's had an enormous impact in not only the ability to make progress, but to educate this broad band of investigators we have now that are studying cancer immunology and immunotherapy. So I think SITC deserves a lot of credit for that. Certainly the other major organizations like AACR and ASCO, and they were very slow to come to immunotherapy, whereas SITC was the leading organization in the field to do that.
Well, it's really been an honor to talk to you today, and so much fun as well. Is there anything else you'd like to bring up?
No, just again, my thanks to you and the leaders of SITC for having me as part of the organization. So let's keep at it. Let's get back to work.
We still have a lot to do, don't we?
We certainly do.
As long as 600,000 people are dying a year, we've got to do something about that.
Yes, and I think people at SITC are going to play an important role in that in the future.
Well, thanks so much for your time today. You've been such a major influence in the field. You've helped so many of us see how the immune system can be a very powerful tool for fighting cancer. And your work at the NCI will continue to inspire and help many patients. And you've inspired many investigators throughout the world to continue making progress against this disease. So thanks so much again for your time today.
You're very welcome, Pat. It's been a pleasure to talk with you.